Alright guys, we are going to start a new unit, Unit 10, and it has to do with something called stoichiometry. And basically we're going to be taking all of these mole ideas that we've been working with, and we're going to relate them to balanced equations. So the definition of stoichiometry is the study of quantitative relationships between the amounts of reactants used and amounts of products formed by a chemical reaction. And it's all based on the law of conservation of mass, where the mass of the reactants equals the mass of the product. So when a chemical reaction happens, we never gain mass, we never lose mass. The atoms are just rearranged. So the mass of the reactants will always equal the mass of the products. And as you can see here, if we have this balanced equation where 4 iron plus 3 oxygen yields 2 iron oxide, if we were to look at that in terms of atoms, 4 iron atoms, 3 molecules of O2, 2 formula units of Fe2O3. It's balanced, right? We have 4 Fe's and 6 O's on both sides. That also applies to moles. So these coefficients are not only how many atoms there are and how many molecules, but they're also how many moles of each thing are in the balanced equation. So 4 moles of Fe reacts with 3 moles of O2 to make 2 moles of Fe2O3. And then if we took those mole values and converted them to grams using the molar masses of the reactants and the products, we would see that the total mass of the reactants equals the total mass of the products. That's the law of conservation of mass. And these moles that the coefficients represent, that's what we're going to be focusing on in this unit, or that we have to have that balanced equation to get those moles. All right, so let's look at an example. The combustion of propane provides energy for heating homes, cooking food, and soldering metal parts. Interpret the equation for the combustion of propane in terms of representative particles, moles, and mass. Show that the law of conservation of mass is observed. Okay, so let's take a look. So the first thing we need to do is we need to write our balanced equation. And we know that in combustion, we take whatever we are given, C3H8, it reacts with oxygen gas. And the two products of combustion are CO2 and H2O. All right, and then we need to balance our equation. So if we balance it, we have 3 carbons, so we'll put a 3 there. We have 8 hydrogens, so we'll put a 4 there. 3 times 2 is 6, plus 4 is 10 oxygens, so we put a 5 there. Okay, so let's talk about what this equation means. Well, it means that 1 molecule of propane reacts with 5 molecules of oxygen to produce 3 molecules of CO2 and 4 molecules of H2O. Okay, so that's in terms of representative particles. Or we could say 1 mole of propane reacts with 5 moles of oxygen to make 3 moles of CO2 and 4 moles of H2O. That's in terms of moles. Now, if we want to look at it in terms of mass, we have to convert our moles to grams, okay? So that means we need the molar masses. So if you're looking at your periodic table, 1 mole of C3H8 has a mass of, we would add it all up, 3 times carbon plus 8 times hydrogen, and that would give us 44.097 grams. That's the mass of 1 mole of C3H8. And then we want the mass of 5 moles of O2. So 5 moles of O2 has a mass of 5 times O2, which is 31.998 grams. So this 5 times 31.998 is 159.99 grams. Okay, so that's the mass of the reactants. Now we want to look at the mass of the products. So the mass of 3 moles of CO2 would be 3 times the molar mass of CO2 from the periodic table, which is 44.009 grams. If we multiply that, it gives us 132.027 grams of CO2. And then we have 4 moles of H2O, which would be 4 times the molar mass of H2O, which is 18.015 grams, excuse me, grams per mole. If we multiply that, we get 72.06 grams of water. Okay, now let's show that they're equal. So if we add 44.097 plus 159.99, that gives us 204.087 grams. If we add 132.027 plus 72.06, that gives us 204.087 grams. So yes, the balanced equation does observe the law of the conservation of mass. Okay, so now let's take our balanced equation and find what are called mole ratios. And a mole ratio is a ratio between the number of moles of any two substances in a balanced equation. So let's go back to our balanced equation that we were just using, the one with propane in it. So in our balanced equation, we have, I can get, there it is, C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. Okay, so when we're writing mole ratios, you can take any ratio between any substances in our balanced equation. So we can make a mole ratio between the two reactants, which would look like this. For every 1 mole of C3H8, we would need 5 moles of O2. That would be a mole ratio. Okay, now just like any other conversion factor, we can flip it upside down. So we could also say 5 moles of O2 over 1 mole of C3H8. Okay, and you'll have to decide which way you need it based on your balance, or based on your calculation that you're trying to do. You can also make a mole ratio out of reactants and products together. So for example, 5 moles of O2 for every 3 moles of CO2. Okay, that would be a mole ratio. You could also make mole ratios out of just products. So 3 moles of CO2, 4 moles of H2O. So the mole ratio you make and how you flip it over, or which direction you use it, is always going to be based on the problem that you're trying to solve. And you're going to have to decide based on what you're given and what you're trying to find when we do these calculations as to which mole ratio you use. But you have to have that balanced equation because the coefficients are the number of moles of each thing. So if you don't have the right reaction and you don't have it balanced correctly, then your mole ratios are going to be incorrect. So again, you have to be able to write that correctly balanced equation.